Hello, you guys. Let's talk about probability. Boy, did I hear you loud and clear that people really felt it would help if we do small note-taking guides, even when we are trying some of these new activities. Okay, so take a look at probability, defining probability. So remember, in algebra, we use a capital P and then parentheses. So we would say the probability of an event equals what you want to happen over the total number of outcomes. So if they ask us for a probability, we are supposed to give them a fraction, one number over a second number. Now, we talked about the probability number line because probability are only values from 0 on a number line, which means, and you should write this down, impossible, up to 1, which means absolutely 100% will happen. But there is no probability greater than 1, and there's no probability less than 0. But they can be in between. So in the middle, at the halfway point, that's what we say even chances, 50-50 chances. For example, a coin can land on heads or tails. There are two different outcomes for that. So that would be an example of a 50%, equally likely to happen. Something over here at the 1/4 is unlikely, and something over here at 3/4 is likely to happen. That's what we say. Now, definitions of outcomes, that could be all the possible things that can occur, everything that can occur. And so if I'm just saying what are the outcomes for a coin, well, a coin could land on heads or tails. So that would be a total of 2 outcomes. Okay, so I keep using this word outcomes. Well, there are 4 different ways that we can find all possible outcomes for an event. The first way are tree diagrams. Another way is to create tables and fill them out. A third way is to just simply write a list, an organized list. And the fourth way is what we called the shortcut, where we were just multiplying the number of events. So let's take each one at a time. Let's talk about the tree diagram. Let's say I had this. Describe 4 ways to show all possible outcomes if you have 3 flavors of ice cream, chocolate, vanilla, and strawberry, and 4 types of toppings, hot fudge, butterscotch, sprinkles, and nuts. Okay, let's take a look at a tree diagram for this situation. A tree diagram always starts with a point, and then you have to make your first decision. Well, notice how the first thing they said were 3 flavors of ice creams. So I would draw 3 branches, and I would put the ice creams, chocolate, vanilla, strawberry. Now, the next decision I have to make is what type of toppings. So from each type of ice cream, I would have to draw 4 branches for the 4 toppings, because I could have hot fudge, butterscotch, sprinkles, and nuts. On a chocolate ice cream, I could have those same 4, hot fudge, butterscotch, sprinkles, and nuts on a vanilla ice cream. Or for strawberry ice cream, I could have had hot fudge, butterscotch, sprinkles, or nuts. So if you want to count the total number of outcomes using a tree diagram, you go all the way to the right-hand side and you put little dots. See how I put little dots here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 choices. Okay, so another way to figure out all of the outcomes is to use a table. Now, I filled out the table partially for you. So on this side, I put the chocolate ice cream, vanilla ice cream, strawberry ice cream. On the top, I put the toppings, hot fudge, butterscotch, sprinkles, and nuts. And then you go to the box and you use both items. So I grab the chocolate and the hot fudge. So one choice is chocolate ice cream with hot fudge. Another choice would be chocolate ice cream with the butterscotch topping. Another choice is chocolate ice cream with sprinkles. Another choice is chocolate ice cream with nuts. And then I could go through vanilla with hot fudge, vanilla with butterscotch, vanilla with sprinkles, and vanilla with nuts. And then the strawberry choices, strawberry with hot fudge, strawberry with butterscotch, strawberry with sprinkles, and strawberry with nuts. So you can see from the table there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 choices in our table, and that means there were 12 outcomes. Now, another way to do this is just to list all the choices. And so all I did was list the choices, and you can see they're the exact same thing as in the table. So a list should be neat and organized. But again, there are 12 choices. Now, the shortcut was what we talked about in class. I would just draw a line for my first decision, the ice cream decision. I knew I had 3 choices. Then I would draw another line for the topping decision, and I knew I had 4 choices. And then I just multiply those two. So 3 times 4 would give me 12 outcomes. Now you can use a shortcut anytime they just ask for the number of outcomes. If they don't make you list them all, then just use a shortcut. Okay, guys, well, my cat, Kitty, is here. She wants to help with probability. So if you hear purring, I promise it's not me, it's her. So take a look at number 6, calculating probability of one event, just one thing happening. So remember, probability of an event is what you want to happen over the total number of outcomes. And remember, I'm talking about just one event in this example. So look at letter A. Find the probability of making a basket if you made 12 baskets in your last 80 shots. So the probability of me making a basket based on this information would be 20 because I made 20 baskets over 80 because I shot 80 times. And so then just reduce a fraction. So I would divide both the numerator and denominator by 20. So the probability of me making a basket is 1 out of 4, or 1/4. Take a look at example B. What's the probability of picking a vowel from the letters in the word mathematics? Well, I count the vowels. A is a vowel, E is a vowel, A is a vowel, I is a vowel. So I see 4 of them. So the probability of picking a vowel would be 4 out of the total number of letters. And if you count the total number of letters, it would be 11. So it would be 4 out of 11. Okay, take a look at number 7, calculating the probability of 2 or more events. Okay, so the probability of both events equals the probability of the first event times the probability of the second event. So find the probability of getting a head and a 5 when flipping a coin and rolling a number cube. So I wrote it like this, a probability, and then in parentheses I put of getting a head and a 5 equals the probability of getting a head on the coin times the probability of getting a 5 on the number cube. So the probability of getting a head is just 1 out of 2. And then I put the time symbol, and the probability of getting a 5 on the number cube was 1 out of the 6 numbers. And so then I multiplied. 1 times 1 is 1, 2 times 6 is 12. So the probability of getting a head and a 5 is 1 out of 12. Now look at B. Find the probability of choosing the letter A from a bag containing the letters A, B, C, and D and getting an even number when rolling a number cube. So I wrote a capital P for the probability of getting the A and an even number. So I first have to figure out the probability of picking an A. Well, A is 1 letter out of the 4 letters I could have drawn from, and then I bring down the time symbol. The probability of getting an even number on the cube, well remember on the number cube it goes from 1 to 6, so I know 2 is even, 4 is even, and 6 is even. So that means I have 3 chances out of 6 to get an even number. So then I multiply those fractions. 1 times 3 is 3, 4 times 6 is 24. I reduce and I get 1 out of 8. Now the movie clue is I said the wrong number when I was explaining an example. You need to tell me what I said and what the number actually was. Okay, so I did say something wrong. So be careful, listen, and write the movie clue right down here.